Okay, so today we're going to talk about how we use the two congruent triangles once we have proved the two triangles are congruent, either using SSS, SAS, ASA, AAS. Those are the four shortcuts that we talked about so far. So once we prove the two triangles are congruent, then you could use this idea that the corresponding parts of congruent triangles are congruent. So in short, we just use the CPCTC, which is the first letter of each one of those words there. Corresponding parts of congruent triangles are congruent. And so once we prove two triangles are congruent, then the besides the three things that we used, whether it's SSS, SAS, and ASA and AAS, we can show that the other parts, other angles, or other sides that we did not mention are also congruent using this idea that the corresponding parts of congruent triangles are also congruent. So that's the CPCTC that we're going to use in any kind of proof once we know that the two triangles are congruent. And so here, if I have this triangles here, so sometimes when you have triangles sort of mixed like this, it's easier to kind of separate the two pictures. And so the left side here is drawn here. So that's the triangle CST. And then the right side triangle here, the DST, is drawn here separately. And so sometimes it's easier to separate the two triangles that you're looking at. That way you don't have to worry about this overlapping part because sometimes it's a little confusing. So instead of marking, just on the picture here, where it says SD here is congruent to TC. So if I mark SD is congruent to TC, now if I mark it like that, we're not sure we're talking about just those two smaller segments or the whole thing. And so it's easier if you separate it. So then you could say SD is congruent to TS, right? And then CS is congruent to DT, so we can mark it here. So this one is not confusing here, but then you could also mark here, CS is congruent to DT, right? And then again, the overlapping part at the bottom, ST, is congruent to itself, right? So this one, you could just mark it here, which is congruent to itself, or you could mark it here as well, right? So when you have overlapping picture like this, sometimes it's easier to separate the picture. So then we can see that the two triangles are congruent by side, 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 right? Because all three sides here are congruent to all three sides there. So then that means not only the three sides are congruent, and because now we know that the two triangles are congruent, all the corresponding angles will also be congruent as well. And so you can pick any one of these angles, but we're trying to just prove one of them here, which is angle SCT, which is this one right here. So the angle SCT, right, here is going to be congruent to angle TDS here. So any matching or corresponding angle, so angle S and angle T, and then this angle T and angle S here, they will all be congruent, but we're just using, or we're just trying to prove these two angles congruent. And those two angles are congruent by this idea that the corresponding parts of congruent triangles are congruent. So once again, instead of writing all that out, you could just say CPCTC, which stands for corresponding parts of congruent triangles are congruent, right? And so once you prove the two triangles are congruent, you can use CPCTC to say any of the other three corresponding parts, whether they're angles or sides, are also congruent. So that's the idea that we're using today, right? So once we prove two triangles are congruent by SSS, SAS, ASA, AAS, then you can use CPCTC to say any other corresponding angles in this case, or even corresponding sides are also congruent as well, okay? So then here we have another example with, overlapping pictures here. And so if we're trying to do the two-column proof here, so we start with the given information. So I just copied all the given information and it's already marked here, right? And then I know that this overlapping part in the middle is congruent to itself. And so I could just say that the segment XY is congruent to segment XY, which is the reflexive property of congruence, right? So that's the reflexive, right? So that's the reflexive property of congruence, right? So it's just congruent to itself. So then you can tell on the picture that these two triangles are congruent by angle, side, angle, because we know two angles are congruent to two angles here, and then the side is the included side between the two angles. So these two triangles are congruent by angle, side, angle, congruence postulate, right? So then once we establish that the two triangles are congruent, then the rest of the corresponding angles and the rest of the sides are always going to be congruent as well. And so we're just trying to prove this side here. Now we could have chosen any two sides or even the third angle there, but the WX is going to be, now again, look at the letters here. WX is the first and the last letter, which is congruent to ZY. And so we know that the WX is going to be congruent to ZY as well. And that's the corresponding parts of congruent triangles are also congruent. So that's the CPCTC. Okay. So once we prove the two triangles are congruent, any corresponding sides or any corresponding angles are congruent by this idea of CPCTC. That's the corresponding parts of congruent triangles are congruent. Right? So you could only use this after you establish that the two triangles are congruent first. Okay? All right. So here's several triangles that you can look at. So this is where it helps sometimes when you separate the triangles, if it makes it easier. Sometimes you can, mark it on the picture like this, but notice there's several triangles here that we're going to use to get to the proving the angle GJM here at the bottom is congruent to angle HJM. That's what we're trying to get to, right? And so somehow we want to establish, right, that the two triangles at the bottom are congruent. Once we know that these two triangles at the bottom are congruent, then any corresponding angles or any corresponding sides will also be congruent, right? However, we're not given much information here on the top. And so we're going to first use the given information here on the top and get to the bottom triangles here, right? And so first we copy the given information. And so we know that the segment GF here is marked congruent as segment HF. And then we know angle 1 on the top is congruent to angle 2. So those are all marked on the picture, right? That's given. Now we know that this segment that's on the top here that is in the middle, the segment FM is congruent to itself, right? That's the reflexive property, right? And so you could even mark it on the picture here if you wanted to. And so then you can tell here that these two small triangles on the top are congruent, right? By the side angle side congruent to the side angle side. So the two small triangles on the top, this triangle FGM is congruent to triangle FHM by the side angle side congruence here postulate, right? And so side angle side is congruent to side angle side. So that means everything on the top two triangles are going to be congruent. All the corresponding sides and all the corresponding angles, right, are going to be congruent. And so we're going to use this corresponding parts here, which is the segment GM and the segment HM. So we can mark it with 3 slashes here, because that's the corresponding sides on the top two triangles. We already established these two triangles are congruent. And so we use the last two letters here, and then the last two letters here, and that's the CPCTC, right? That's the corresponding parts of congruent triangles are congruent. We establish the top two triangles are congruent already using SAS. So then we can choose any of those corresponding sides or angles and say they're congruent, right? And then we need these two sides because so we can use that at the bottom triangles. And so we chose those two segments to be congruent by CPCTC, right? Now we also know that these two are right angles right here, right? That's given to us, right? So that's the given information here. And because they are right angles, they're going to be congruent to each other, right? Because that's the right angle congruence theorem. That means all right angles are congruent. And so you could even mark it here that the angle on the left is congruent to angle on the right. Okay, so that's the right angle congruence. And we also know that the MJ here, now we get lots of slashes here. So we did 1, 2, 3, 4 slashes. Now that's congruent to itself, right? So MJ is congruent to MJ. That's reflexive, right? We saw that quite a bit. So that's the reflexive property of congruence, right? So that's congruent to itself, right? So then we establish on the picture here that the side angle side is going to be congruent to that side, that angle, and that side. So the two triangles at the bottom that we are trying to get to are congruent by side angle side congruence postulate again, right? And so then once we establish these two triangles at the bottom are congruent, any corresponding angles or the sides are going to be congruent. So namely, we're trying to get to prove those two angles at the bottom. So this angle, GJM, is what we're trying to prove. So I'm going to put two arcs here because I already put one arc on the top and then two arcs here. So those two angles are congruent because that's the CP corresponding parts of congruent. That's the CPCT for the triangles are congruent. So that's the CPCTC, and by CPCTC, these two angles are going to be congruent. Now, those two other angles here and here are congruent too, if you wanted to show that as well, right? And then this side and that side is also congruent by CPCTC, but you can show any one of those three, but we're just trying to show these two angles, so that's what we ended up with, right? So that's how we use the CPCTC. Now, notice we only use CPCTC after we establish that the two triangles are congruent. We did that twice. We did that here on step 4, and we did that here on the final step. Okay? So CPCTC is only after you know that you proved or you established that the two triangles are congruent. Okay? All right. So here's another proof using CPCTC as well as the SSS, SAS, and AAS and ASA. And so here, let me just kind of erase the information here and then we'll start, right? So we are given all this information, right? And so I just kind of put the arrow here. So instead of writing all that down, so we're just going to copy all that given information as our first step. And so that's our given, right? And then we mark it on the picture, right? So we mark that all these are right angles here, right? That's a right angle, that's already marked. And then the other side is right angle. And then the YN, right, is congruent to YQ, it's already marked. And then angle N is congruent to angle Q, it's already marked, okay? And so if you look at the picture, the reason we mark it, because it's easier to see on the picture when you mark it, right? And so you look at the triangles on the right side, the triangle ZNY here is going to be congruent to triangle ZQY because this is the angle, angle, side. This is the angle, angle, side. Notice that the side is not between the two angles that we marked congruent, right? But it's outside of that, so that's why it's angle, angle, side, not angle, side, angle, right? Remember the location of that side is important. If it's in the middle, then you put ASA. If it's not in the middle, then you put AAS, okay? So then these two triangles are congruent. And so now we know these two triangles are congruent, right? We could say that this angle NYZ, so this, I'm going to mark it here, is congruent to the other angle QYZ. Why? Because that's the corresponding parts of congruent triangles are congruent. So once you establish that the two triangles are congruent, then any matching angles, these two are matching angles, right? They're congruent, as well as the matching sides, as well as the other angles as well. So then we establish that those two angles are congruent by corresponding parts of congruent triangles are congruent, CPCTC, okay? Now, why do we do that? So that we can use those angles and the idea that the vertical angles are congruent. So then this angle here on the top is going to be vertical angle with this one, right? So then we establish that the angle NYZ is going to be congruent to the vertical angle here, PYX. And the same thing with the other one here, right? So this bottom angle is going to be congruent to the vertical angle here on the top. So that means all four of those are going to be congruent, right? So then you just write all those. So this angle QYZ is congruent to that angle MYX, right? And those two angles are congruent by vertical angle theorem. So then notice what we have here. We already knew that the NYZ and the QYZ are congruent to each other. So that means using the transitive property, even though we're comparing four things here, remember transitive property could compare three or more. And so since these two are congruent to each other here on step 3, that means the other two that I mentioned here are going to be congruent to each other as well. That's the transitive property of congruence. And so then I just make these two congruent. Obviously, we already marked it on the picture. It's easy to see, right? And then, so we had these two right angles congruent, and we had these two angles are congruent now. And then we have this here in the middle, that's the reflexive. The xy is congruent to the segment xy, reflexive property. And so then these two triangles now, that's what we're trying to prove, are congruent by angle, side, angle, because the side now is in the middle of the two angles that we're looking at. So that's two triangles are congruent on the left side, right, by angle, side, angle. And so our proofs got a little bit longer and complicated because we're kind of dealing with more than just two triangles, right? But we're doing kind of a similar thing. It's just that it's a little bit longer because now we're trying to relate all four triangles like this. Okay. So again, the CPCTC is only after you establish that the two triangles are congruent. Okay, so once again, if I have some information like this, I already kind of marked it here for you. That's the given information, right? So I copy all the given information, right? The HG is congruent to HJ. It's marked here on the picture. And then segment GK is congruent to segment JK. It's marked with the two slashes there, right? And then segment HK in the middle here is congruent to segment HK. Well, that's congruent to itself, right? So I could put three slashes there. So that's the reflexive. That's the same thing, right? HK is exactly the same thing. That's like a mirror reflection. So that's the reflexive property of congruence, right? It's a congruent segment, but you could just write property of congruence. And then so you can tell here on the picture that the triangle on the top is congruent to triangle at the bottom by side, 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 right? So the HGK on the top is congruent to HJK at the bottom by side, 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 right? So all three sides are congruent to all three sides of the bottom triangle. So then once you establish that the two triangles are congruent, then all the corresponding parts of congruent triangles are congruent. That's the CPCTC. And so that means this angle 1 and angle 2 are the matching angles of the two triangles. So angle 1 and angle 2 are congruent by CPCTC, right? And so that means since this angle 1 and 2 are congruent, right, that is what we're trying to prove here, is that the angle GHJ is bisected by this ray HK, because by definition of angle bisector, when you bisect something, it's going to cut in half. It's going to give you two congruent angles there. And so because angle 1 and 2 are congruent, that is going to tell you that the angle GHJ is bisected by the ray HJ and HK in the middle, and that is the definition of angle bisector, right? So when you bisect something, it's going to cut in half, and it's going to give you two congruent angles there, okay? And so that's how we can use a lot of different information that we looked at so far to prove, first of all, the two triangles are congruent by SSS, SAS, ASA, AAS. And then once you show the two triangles are congruent, you could then pick any corresponding angles, any matching angles, or any matching sides, and say that they're congruent as well. And that's the idea of the CPCTC, which is just the first letter of saying corresponding parts of congruent triangles are congruent. Okay? All right. Thank you very much.